Hello guys, it's Syed Muhammad Lucas. Many people were requesting me to make video regarding chill water pump head calculation. So today I'm going to make video on this topic. So let's start. So before starting this chill water pump head calculation, I'm going to explain you guys the main difference between primary and secondary chill water pumps. As you can see that I have this drawing of the chiller yard. You can see that I have a chillers over here, and then we have secondary chilled water pumps and then primary chilled water pumps over here. So what is the main purpose of this secondary chilled water pump and the primary chilled water pump? So primary chilled water pump is basically, this primary chilled water pump is basically taking water from the building and push to the chillers, while this secondary chilled water pumps, they are taking water from the chillers and push to the building. So I will explain you over here in this chiller yard drawing. As you can see that this is our primary chilled water pumps and these are the chillers. So secondary chilled water pump basically taking water from chiller and push to the building. So this is the supply side of the chiller. As you can see that from this arrow, it is supplying water from the chillers. It's coming from here like this, and it is going into the secondary chilled water pumps. After secondary chilled water pumps, it is circulating over here through this line, and then it supplies to the building over here. And primary chilled water pump is taking water from buildings and push to the chillers. As you can see that this is the return. This one is the return from the building. This return is coming from here through this pipe and then going inside the primary chilled water pumps, as you can see over here. Then it's circulating back from this pipe like this, and is coming back from here into the chillers. So this is the main function of this primary pumps and secondary chilled water pumps. So let's start the pump head calculation. As you can see that I have Excel sheet over here. So I'm going to explain you the pump head calculation for secondary chilled water pumps. As you can see that this is the drawing I have, in which I will show you the pump head calculations. So you can see that we have a chiller over here that is has capacity of 200 tons, and we have a 4 air handling units over here, 1, 2, 3 and 4, each with a capacity of 50 ton. And you can see the supply piping from there going into secondary chilled water pumps, 1, 2, 3, and then it's going into the air handling unit 1, 2 and 3. And we know that we have a chiller of 200 TR and GPM is 480 GPM, as you can see over here, 480 GPM, and the pipe size is 5 inches, and each air handling unit with the 50 ton of refrigeration capacity. And how much is the GPM over here is 120 GPM with a pipe size 3 inches for each air handling unit. So as you can see, the pipe size over here is 5 inches. Flow rate changes to 360 GPM because 120 move over there, again 120 move over there to air handling unit 2. So we are left with 240 GPM, 4-inch pipe size, and 120 GPM over here in air handling unit 3, and 120 GPM here to the air handling unit 4. So if you want to know how did we get this GPM and tonnage, you can see my previous tutorials regarding pipe sizing and heat load calculations. As you can see that we have divided this piping into different sections from A to B, B to C, C to D, and F and G, H, I, J, K and L up till L. And you can see the section length for secondary chilled water pump over here, A to E 5 feet, B to C 5 feet, and so on up to K to L, that is 16 feet. have divided this piping into different sections to calculate the pump head. But before starting the calculation, you need to know one more thing. In order to calculate the pump head, we need to find the most hydraulically remote circuit in our chilled water system. As you can see that this is the supply piping for secondary chilled water pumps from there to point K to L, and we know that K to L 16 feet, and I did not write over here, but from K to air handling unit 4 length is 10 feet. So this is our longest run of piping up till point L. So this is our most hydraulically remote circuit over here up to point L. So let's move back to our Excel sheet to start pump head calculations. As you can see that I have divided the piping into different sections, A to I, I to J, J to K, and then K to L. Why did I write from A to I directly? Because if you see that over here, our GPM and pipe size is constant up till point L, up till point I. So after point I, our GPM and pipe size is changed. So that's why we keep the same from section A to section I. Here we have 480 GPM and 5-inch pipe size from section A to section I. 5-inch pipe size, 480 GPM. So as you can see over there, we have a pipe size 5 inches. So what we have over here from section A to I, we have a straight pipe, we have a gate valve, we have butterfly valve, strainer, elbow, NLV, and DRV. I will explain you each one of this in detail, how we get these fittings section A to I. So let's start this first one. Pipe, we have a straight pipe, this one up till point I. We have a total length. How much is the total length we have from section A to section I? As you can see that A to B 5 feet, B to C 5 feet, C to D 5 feet, and then up to section I we have that much. So 5, 10, 15, 20, 21, 36, 36 and 20, 56, and then 10, 66. So section A to I we have 66 feet length of the pipe. So move back to our Excel sheet. You can see that the length over here is 66 feet, and if you want to convert this length into meter, you need to multiply this length with 0.3048. you will get in meter. And we know that we have a 5-inch pipe size, 480 GPM is the flow rate. We already checked from there, 480 GPM, 5-inch pipe size. So if you want to convert this into liter per second, you need to multiply it with 0.06308. you will get in liter per second. Now I will tell you how did we get this friction. So in order to show you, I will open this pipe sizer for you. So the pipe which we are using over here is flat steel schedule 40, and you see that pipe size is 5 inches and flow rate is 480 GPM. So flow rate and pipe size is 5 inches and flow rate is 480 GPM. As you can see, the head loss over here is 3.895 feet per 100 feet. So this is how did we get this friction, that is feet per 100 feet in the straight pipe with the flow rate of 480 GPM and pipe size is 5 inches. So move to our next column, that is equivalent length. Since we already got the straight length of the pipe, so there is no equivalent length for this pipe. This is only for the fittings and the walls, so it will be 0, number of fittings 0. If you multiply and if we move to next column, that is total equivalent length in the straight pipe. So how did we get this total equivalent length in the straight pipe? We need to multiply this equivalent length time number of fittings plus the length which we have calculated over here, the linear length of the pipe, that is 66 feet. Since this one is 0, so we have only 66. That's why total equivalent length in a straight pipe is 66 feet. So moving to our next column, that is head loss. How did we get this head loss? We simply need to multiply this our friction, that is feet per 100 feet, that is 3.895, with this total equivalent length in the straight pipe. You will get this head loss. So as you can see that friction over here is 3.895 and equivalent length in a straight pipe is 66. If you divide it by 100, you will get the head loss. With 5-inch pipe size and that much friction rate, we will get the head loss of 2.57 feet. So this is 2.57 feet. Now I will show you the fittings which we have from section A to I. So this from section A to I. What are the fittings we have? So in order to give you a better idea, let me show you in this chiller yard drawing. Since we are working with the secondary chilled water pumps, and we can see that this is the section of the secondary pump. This is the pump header, as you can see over here. And what are the fittings do we have on the suction side and the discharge side of the secondary chilled water pump? As you can see, on the suction side we have this butterfly valve and we have a strainer. On the discharge side we have a swing check valve and the butterfly valve. So we have a one butterfly valve and one strainer, one swing check valve and one butterfly valve. So total 2 butterfly valves, one strainer and one swing check valve. Also we have a one gate valve over here from the supply side of the chiller. As you can see that this is a motorized gate valve over here on the supply side of the chiller. It is supplying from here and going into the secondary chilled water pumps. So we have a one gate valve over here, and other things I have already explained you on suction and discharge side of the chilled water pump, secondary chilled water pumps. That is 2 butterfly valves, one strainer and one check valve. Let's move back to our Excel sheet. You can see that gate valve over here, that is 1, butterfly valve we have 2, strainer 1, NRV, that is non-return valve or swing check valve, that is 1, and elbow, we need to check the elbows. So if we move back to our drawing, from section A to section I, how many elbows we have? 1, 2, 3, 4, 5. So up till section I we have 5 elbows. So elbows we have 5 over there. So only one thing is remaining, that is DRV, double regulating valve. So on the pump side we will have one DRV, that is double regulating valve, to balance the chilled water flow rate across the secondary chilled water pumps. So we will have one DRV from section A to I on the secondary chilled water pump side. So now pipe size is same, that is 5 inches for all these fittings, and linear length for these fittings is 0. We need to get the equivalent length from here. So linear length is 0 for these fittings, and flow rate we know that 480 GPM for all of them up to section I. If we need to convert this into liter per second, we can convert by this conversion. And now we need to know, the important thing over here is we need to get the equivalent length of this fitting or the valve. The valve over here is gate valve, and how much is the size? 5 inches gate valve over here with 480 GPM. So we need to calculate the equivalent length in a feet. So I will open the table over here to give you the idea how to calculate this equivalent length. Okay, this is the wall over here. As you can see that gate wall over here, and we have a 5 inches gate wall. So you move to the right side 5 inches gate wall, 5 inches gate wall over here. You see the equivalent length is 6 feet over here. So this is how we get the equivalent length of 6 feet. Number of fittings, we have only one wall over there. If you multiply this equivalent feet with the number of fittings, you will get equivalent length. Again, you need to multiply this equivalent length with number of fittings and add this length. Since this is 0, so we have total equivalent length in the straight pipe is 6 feet. Same way you will get the head loss. You need to multiply this total equivalent length in a straight pipe with this friction. Friction will be same. Already I told you how to calculate this friction by using a pipe sizer. You need to multiply 3.895 with this total equivalent length divided by 100. You will get head loss, that is 0.23 feet head loss across this gate wall. Now move to the butterfly wall. We have 5-inch pipe size, the 5-inch butterfly wall over here, so we need to calculate the equivalent length. Since butterfly wall is not over here, we can go for the gate wall. Same 5-inch pipe size, that is 6. So again 6, but we have 2 butterfly wall over here, as we already checked that on the section of the secondary chilled water pump. We have a 2 butterfly walls, so 6 into 2, that is 12. Same way you get the head loss. So move next, strainer. We have a 1 strainer over here, 5-inch strainer, 480 GPM. So we need to get the equivalent length. How much is the equivalent length for 5-inch strainer? As you can see that we have a Y type strainer over here. We have a 5-inch strainer. If you move over there, we have a flanged end strainer, Y type. How much is the equivalent length? That is 80 feet. 5-inch, 80 feet. So we can use 80 over here. Since we have 1 strainer, so 80 into 1, that is 80. Again, you need to multiply this equivalent length with friction, that is feet per 100 feet, divide by 100, you will get this head loss. So move back to our elbow. We already know we have 5 elbows over here. So we need to calculate the equivalent length in a feet for this elbows, 5-inch elbows. Since we are using long radius elbows over here, depending on the site condition, we can use standard elbows, but we are using long radius elbows, 5 inches. So we need to get this equivalent length. As you can see that we have this one, this one. As you can see that we have long radius elbows over here. This is a standard elbow, this is the long radius elbow, 90 degree. So we have a 5-inch pipe size. You can see that 5-inch pipe size with the long radius elbow, that is 8.2. 8.2 is the equivalent length for 5-inch elbow, 90 degree long radius. You can see over here 8.2. So this is how we got this equivalent length, 8.2, 5-inch pipe size. So since we have 5 elbows, 8.2 into 5, that is 41. Again head loss is 41, that is equivalent length in the straight pipe. Multiply by friction rate, you will get this head loss. This is how you can calculate the head loss to the elbows. Now the next fitting which we have over here is NRV, non-return valve, or the swing check valve, that is 5-inch pipe size. So let's move back to our chart to get the equivalent length for this NRV. As you can see that this swing check valve here, 5-inch pipe size. So move back to the right, move to the right side, 5-inch pipe size with the swing check valve. How much is the equivalent length? That is 50 over here. so we can use this 50. You can see that number of fittings we have 1 and equivalent length is 50. Same way you can get the head loss. So next we have a DRV, that is double regulating valve, 5-inch pipe, 5-inch size. So move back to our chart to get the equivalent length for DRV. This is our DRV, that is double regulating valve. Since we are using 45 degrees DRV, 5-inch pipe size, 45 degrees DRV, we got 58 equivalent length. So DRV 5-inch pipe size, 480 GPM, got one DRV, that is 58, that we already checked from the chart. So total equivalent length in the straight pipe is 58. Same way you can calculate the head loss. Simply need to multiply this equivalent length in a straight pipe with this friction. You will get the head loss. Divide by 100, you will get the head loss. So the next section is I to J. Next section is I to J. I to J, there is no fitting, only straight pipe is there. As you can see that pipe size is same, only the flow rate is changed. So flow rate is 360 GPM and pipe size is 5 inches. 5 inches pipe size and flow rate is 360 GPM. And how much is the length we have over here from I to J, that is 12 feet. From I to J you can see that we have a 12 feet length. So we have a 12 feet, that is equal to 3.66 meters, flow rate 360 GPM, that is 22.71 liter per second. And again we need to calculate the friction, that is feet per 100 feet. How did we get 2.261? Again we go to the pipe sizer tool. We have a 5-inch pipe size with 360 GPM this time. So how much is the head loss? 2.261 feet per 100 feet. You can see that 2.261 feet per 100 feet. So this is the straight pipe. We already calculate the linear length, that is 12 feet. So total equivalent length in the straight pipe will be 12 feet, that is over here. And head loss will be, you need to multiply this total equivalent length in a straight pipe with friction rate divided by 100, that is 2.261 multiplied by 12 divided by 100, that is 0.27 feet. That is 0.27 feet over here. Now if we move to the next section, that is J to K. From J to K, you see that we have a straight pipe. Also you notice that from 5 inches to 4 inches, so pipe size is changed. So we will have a reducer over here, 5 to 4, 5 by 4 reducer. And the GPM over here is also changed, that is 240 GPM. Also we have no reducing T over here to the point K, no reducing T at the point K. So we have a 4-inch pipe size, 480 GPM with the straight pipe, reducer, and the no reduction T. So move back to Excel sheet. See that we have a pipe, 4-inch pipe size, 240 GPM, reducer, 4-inch, 240 GPM, no reduction T, 4-inch, 240 GPM. So what is the straight length of the pipe from J to K is 14 feet. From J to K, 14 feet. Okay, that is 14 feet, 240 GPM. And we need to calculate the friction rate again with 4-inch pipe size, 240 GPM. 4-inch pipe size, 240 GPM. How much is the head loss? 3.255 feet per 100 feet. 3.255 feet per 100 feet. Since this is a straight pipe, so no equivalent length, no, for it will be 0, and total equivalent length will be same as the linear feet over here, that is 14 feet. Head loss you need to calculate, you need to multiply this with this, divide by 100. Now we have a reducer, 5 inches to 4 inches reducer. For reducer, how did we get this equivalent length? 3.8. So let's move back to our chart. Okay, this is the table we are going to use to calculate the equivalent length for the reducer. As you can see that we have a sudden enlargement, sudden contraction, and two other. So since we are calculating the secondary chilled water pump head, so pipe size is reduced from 5 inches to 4 inches. So we have a sudden contraction because pipe size is reduced. In this case, capital D is representing our big size, small d is representing our small size for pipe dia. So 5 inches is capital D, 4 inches is the small d. These are the different ratios over here, 1 by 2 and 3 by 4. So since we have 5 inches and 4 inches reducer, 5 by 4 reducer, so 4 by 5, small d by capital D. I already told you small d by capital D, and ratio is 0.8. 0.8 that is nearly equal to 3 by 4, that is 0.75. So we can get this ratio 0.75, that is 3 by 4 over here, and we have a reducer 4 inch size over there. So move to the right side with the 4 inch size, and 3 by 4 ratio, we got 3.8 is the equivalent length over here, 3.8. So this is how we got the equivalent length 3.8 for the reducer, 5 by 4 reducer, 4 by 5 reducer. Since we have one reducer, so total equivalent length in straight pipe is 3.8. So head loss, again you need to multiply total equivalent length with the friction rate divided by 100, you will get the head loss. And the last one from section J to K is no reduction T. So move to our chart again to find the equivalent length for no reduction T. So this is the chart we are going to use for no reduction T. As you can see that this is the no reduction T over here, and we have a 4 inch size over here. If we move to the right side and 4 inch no reduction T, we got 6.7 equivalent length. 6.7 over here is the equivalent length. So see, 6.7 is the equivalent length for no reduction T. Only one T is there, so we got the head loss over here is 0.22 feet. So now move to our next section, that is K to L. K to L. To understand K to L section, we have I will open one image for you to get the better understanding. As you can see that this is the supply side of the air handling unit, and this one is the return side of the air handling unit. Since we are calculating the pump head, secondary chilled water pump, that is supplying water from chillers pushed to the building. So this is the supply side we need to consider for secondary chilled water pump. So what are the fittings we have on the air handling unit supply side? This is the gate valve, and this is Y-type strainer. So we have two fittings, and this one is a two-way valve. You can use this for primary chilled water pump head calculation, and this is the DRV double regulating valves. So right now we consider only this two things, that is Y-type strainer and gate valve over here, because we are calculating the secondary chilled water pump head right now. So we have two fittings over here, as I already showed you in the image, that is gate valve and the strainer from point K to L. Also notice one thing, the pipe size is reduced from 4 to 3 inches, so we will have a reducer over here also. If we move back to our Excel sheet, you can see over here we have a pipe size 3 inches, gate valve strainer and reducer. So these are the three things which we have in this K2L pipe: gate valve, strainer and reducer. So we have a 3-inch pipe size over here and 120 GPM, and equivalent length over here we will calculate now. First, linear feet of this pipe is 16 feet. Just confirm from there. K2L 16 feet. Okay, 16 feet which we have used over here for this pipe, 3-inch pipe size. Again we need to calculate this friction for this 3-inch pipe size with 120 GPM. Go to the pipe sizer tool, 3-inch pipe size, 120 GPM. Head loss is 3.433 feet per 100 feet. 3.433 feet per 100 feet. So total equivalent length is 16 feet. You need to multiply with friction rate, divide by 100 to get the head loss. 3.433 multiply by 16 divided by 100, you will get the head loss of 0.55. 0.55 is the head loss. Now the fittings which we have over here is from K2L is gate valve, strainer and reducer. First, gate valve, 3-inch pipe size, same GPM. We need to get the equivalent length of this gate valve, 3-inch gate valve. Okay, we have a gate valve over here and 3-inch gate valve. Move to the right side, we got 3.2 is the equivalent length. So 3.2, only one gate valve, so total equivalent length 3.2 in the straight pipe, and you can calculate the head loss in the same way I have explained. So next fitting which we have over here is strainer, 3-inch strainer. So this is a wire type strainer over here and 3-inch. We move to the right side, and since we are using a flange end strainer over here, so equivalent length is 42 over here for the flange end strainer, 3-inch, 42. So 42, and we have one strainer, so total equivalent length is 42, and we can calculate the head loss by multiplying this equivalent length with this friction, divide by 100. So last one is reducer. Same way we will calculate the equivalent length for the reducer. Since the pipe size is changed from 4 inches to 3 inches, move back to the chart. Okay, again there's a sudden contraction from 4 inches to 3 inches. 3 inches representing small d and 4 inches representing as capital D. If we get the ratio of 3 by 4, we will get 0.75, that is 3 by 4 ratio over here. As you can see over here, sudden contraction 3 by 4, and 3 inches we move to the right side, we get the equivalent length for this reducer is 2.6 over here. Move back to the Excel sheet. The reducer equivalent length is 2.6 feet, only one reducer, total equivalent length is 2.6. Again you need to multiply this total equivalent length in the straight pipe with this friction rate, that is 3.433 multiply 2.6 divided by 100, you will get 0.09 feet, that is 0.09 feet. So all sections head loss has been calculated. Now what we need to do, we need to sum all of this to get the total head loss in the feet. So 15.45 is the total head loss in the feet. If you want to convert this into meter, you can use a conversion rate. So 15.45 feet is the head loss, and we need to add some safety factor. We will add 15% safety factor doing it, and total head loss after adding this 15% safety factor, 15% safety factor is 2.32 feet. So total head loss in the feet is 17.77 feet. So secondary chilled water pump head loss is 17.77 feet. So if you want to calculate this brake horsepower of this pump, you can calculate by using this formula, that is GPM into head into specific heat of the water into 3960 into efficiency of pump. Efficiency of pump, normally we are taking 85%, and specific heat, that is 1. If you will put all the values and GPM, we know that total 480 GPM. So if you put all these values, 480 GPM, 17.77 feet into 1 into 3960 divided by 3960 into efficiency is 85%, you will get the brake horsepower, that is 2.53. And you can get the horsepower by just multiplying this with 1.15, and if you want to convert this into kilowatt, you need to multiply this horsepower with 0.746. So the pump head loss is 17.77 feet and the kilowatt is 2.17 kilowatt. So this is how you can calculate the secondary chilled water pump head. In the same way you can calculate the primary chilled water pump head. The only difference between primary and secondary chilled water pump head, you will get the sudden enlargement over there. So you guys can do it on your own. If you find any difficulty, you can let me know, I will help you. So I hope you guys learn a lot from this video. It will be useful for you guys. For more videos, keep watching my channel and don't forget to subscribe.